I'm going to continue this 8-1, just that other video was getting kind of long and I know everybody needed to catch their breath. So let's finish. I only have a few more examples to go through. So the next one here, we're on, it's number 10. We're going to figure out how to integrate. This is actually the easiest one here. Your U, still doesn't want my pencil to be used. Your U is going to be what's under the radical. And then your du is going to be 2x. Makes me slightly happier that this is in purple. And it actually already has 2x, so I don't need to make any sort of adjustment. I just need to identify the form. This is one of our most common U substitution, when that's really all we're doing. We're maybe making a slight adjustment, if any, and then we're establishing what's being done to U. It's in the bottom. It's being square rooted, so it's to the -1/2. So power 1 greater divided by that power 1 greater would be the +1/2, divided by that would be 2 u to the 1/2. So my answer is 2 x squared minus 4 to the 1/2 plus c. Next one, this one kind of looks a lot like the complicated one we did in the last video, but this one actually is very quick. Kind of like the last one. Your u is just your bottom, which is something you want to try first if you have a denominator and a slightly simpler or very similar numerator. Du is e to the x, which is exactly what we have. So this one is perfect. I don't have to do any fancy techniques. I do have to figure out the form. This is in the form du over u, which is a natural log of 1 plus e to the x plus c. Next one. I don't know why it doesn't want to flip screens. Hold on. Move to the next one. Next frame. Here we go. Sorry about that. So now I've just got a few left, and that'll be the end of this video. Just some other things that we've tried. When you are integrating an E1 and you have an exponent of E that maybe is a little more complicated, that's something to try for you. So if we let U be cotangent of X, pretty confident that since the last time we did calculus, you have not once thought about the derivative of cotangent. But the derivative of cotangent, it is negative because all the coderivatives are negative. It is negative cosecant squared, which is what you have except for the negative. So you're going to have a negative adjustment. Sometimes if you can't remember a derivative or you're trying to do a u and a du, look at what the problem has in it, and that'll usually give you a clue. You might forget the negative. That's the common mistake. So then the form, this is in the form e to the u. And the integral of e to the u is e to the u. So you end up with the negative adjustment and then the e to the cotangent x plus c. For the next one, this is one that can be pretzeled. So we can split it up like this. Usually we think of pretzeling with things that are more polynomial based, but it works for trig. When we split up the first one, 1 over cosine is secant. And sine over cosine is tangent. Secant, the integral of secant is a really weird one that we learned at the end of last year. Now I really have to think about it. The integral of secant is the natural log of secant plus tangent. Definitely one nobody's thought about in a long time, including me. Integral of tangent, I always forget the integral of tangent. I know it has a natural log in it. I can think of tangent as sine over cosine and kind of like do a little bit in my head. If I let u be cosine, the bottom, the derivative is negative sine, so there's a negative adjustment. So it's a negative natural log of cosine. That is one of those ones that I said you can either memorize it or you can find an alternate way to remember it, and I like the alternate way of thinking sine over cosine. I don't even write it all out, it just helps. Finally, the last one is an improper fraction, meaning it has a bigger degree on the bottom than the top. So we can do a long division, or I think I'm going to do synthetic division, also something I haven't thought about in a while. So I have a 2, a -3, and a 5. The number that goes outside for the synthetic division is what makes the bottom 0. Drop down the first, multiply diagonally, add, multiply, add. So what we're actually integrating is 2x minus 1 with a remainder of 4 over x minus 1. The integral of 2x is x squared. The integral of minus 1 is minus x, and the integral of the last term is 4 natural log of x minus 1 plus c. So this is truly just a full review of all these different things we've done with integration, from u sub to e's to natural logs to rewriting, algebra techniques, which is really what I wanted to practice, because as we move to the next section of the chapter, we start a brand new technique, and it really helps if you get to review the basics first. So there you have it.